Welcome to Tech Explained. Today, we're diving into something that powers your everyday internet use: IP addresses. Whether you're streaming your favorite show, sending an email, or checking your smart doorbell, IP addresses are working quietly behind the scenes to make sure everything gets to the right place. Think of them as the street addresses of the internet. Without them, your phone, laptop, or smart fridge wouldn't know how to send or receive data. Let's break it all down step by step so it's simple, clear, and maybe even a little fun. All right, imagine the internet is a giant city. Every device, your phone, your computer, even your smart light bulbs, needs an address to live in this city. That's what an IP address is: a unique identifier that tells devices where to find each other. Whether you're loading a website, streaming a movie, or sending a message, IP addresses make sure the data gets to the right device. No addresses, no communication. It's as simple as that. Most of the IP addresses we use today follow a system called IPv4. These addresses look like four numbers separated by dots, like 192 dot something something. But let's not get distracted by the numbers. Instead, let's talk about how they work. Each IPv4 address is made up of 32 bits. Now, don't panic about the word bits. A bit is just the smallest unit of data in computing. It's either a 1 or a 0. So when I say 32 bits, I mean a string of 32 ones and zeros, like this: 11, 0, 1, 10, and so on. But don't worry, you don't have to deal with those ones and zeros because IPv4 simplifies it into those familiar numbers separated by dots. Here's the interesting part. With 32 bits, IPv4 can create about 4.3 billion unique addresses. Back in the 1980s, when IPv4 was designed, that sounded like more than enough. I mean, who could possibly need billions of addresses? But fast forward to today, and we've got smartphones, laptops, smartwatches, smart TVs, even smart refrigerators, all connecting to the internet. Suddenly, 4.3 billion addresses aren't enough. But before we talk about how we solve that problem, let's go a little deeper into how IPv4 is organized. IPv4 addresses are grouped into different classes, which you can think of as neighborhoods in the giant internet city. Class A is like the downtown area: big, wide open spaces designed for massive organizations like governments or major corporations. Then there's Class B, which is more like the suburbs: still spacious, but better suited for universities or mid-sized companies. Finally, we have Class C, the residential zone. This is where most of us live digitally. Your home Wi-Fi router is probably assigning Class C addresses to all your devices. But here's where it gets even more interesting. Not every IP address is visible to the entire internet. Some are private, meaning they're only used inside your home or office network. Think of private IP addresses as house numbers inside a gated community. They make sure your devices, your phone, your smart TV, your laptop, can talk to each other without bothering the rest of the internet. For example, when your phone sends a photo to your printer, it uses your private network. But when you stream Netflix, your router uses your public IP address to communicate with the wider internet. Public IPs are like your street address. They connect your entire network to the outside world. Now, you might be wondering, how does your network know where its boundaries are? That's where subnet masks come in. Let me make this simple. Imagine your neighborhood has a fence around it. That fence defines what's inside your local network and what's outside. Subnet masks work exactly the same way. They help your devices understand this part belongs to our network and everything else is out there on the internet. It's like drawing a line between your home devices and the rest of the digital world, keeping everything organized. All right, let's get back to the big issue I mentioned earlier. IPv4 has 32 bits, which means we only get about 4.3 billion unique addresses. When it was created, no one imagined we'd need more. But today, with billions of devices online, everything from phones to smart speakers to internet-connected coffee machines, we ran out of IPv4 addresses. So what did we do? We created a new system, IPv6. IPv6 is the superhero of IP addresses. Instead of 32 bits, IPv6 uses 128 bits. Now, you don't need to do the math, but trust me, it's a lot more. With 128 bits, IPv6 gives us trillions upon trillions of unique addresses. It's practically infinite, which means we'll never run out no matter how many devices we connect in the future. IPv6 also looks different. Instead of short dotted numbers, it's longer and uses a mix of letters and numbers. But the good news is you don't have to memorize or deal with these addresses directly. Your devices and internet provider handle that for you. So, why does any of this matter to you? First, understanding IP addresses gives you a better appreciation for how the internet works. Every time you send an email, load a web page, or stream a movie, there's an IP address quietly making sure the data gets to the right place. Second, it helps you troubleshoot. Ever had trouble connecting your printer or smart TV? Knowing the difference between public and private IPs or how subnet masks work can make it easier to figure out what's going wrong. And finally, IPv6 is the future. As more devices come online, understanding why IPv6 is important helps you see the bigger picture. Let's quickly recap. IP addresses are like the street addresses of the internet, helping devices find and talk to each other. IPv4 with its 32 bits was great for a while but ran out of space. That's why we now have IPv6 with 128 bits and practically limitless addresses. Public IPs connect your network to the wider internet to each other, while private IPs keep things running smoothly inside your home or office. And subnet masks, they're the fences that keep your local network organized. So next time you're streaming your favorite show, sending an email, or asking your smart speaker to play some music, remember, IP addresses are quietly working in the background to make it all happen. If this made IP addresses a little easier to understand, hit that like button, subscribe to Tech Explained, and let me know in the comments. Have you ever checked your own IP address? What did you learn? Let's talk about it. Thanks for watching, and I'll see you in the next one.